All right, let's delve deeper into asymptotes, and we'll take our first look at limits ever, I believe. So asymptotes, we have vertical asymptotes and horizontal asymptotes. We also have slant, but we'll get there later on. So I'm going to let you attack the vertical there, Mr.
All right,
Griswold.
let's look at vertical asymptotes. I think we have a vertical asymptote wherever we're dividing by 0, right? So wherever we're dividing by 0. So if I have f of x equals x squared plus 2 divided by x squared minus 1, it's wherever x squared minus 1 equals 0, right? So wherever x squared minus 1 equals 0. We could factor this if you want. I guess this is factor. This is going to be x plus 1. We should be pretty quick at these, right? X minus 1. So we're going to have a vertical asymptote wherever x plus 1 equals 0. So at x equals negative 1, or wherever x minus 1 equals 0, just at x equals 1. So we're going to have two vertical asymptotes at x equals negative 1 and x equals 1.
Yeah, and this trick works because two things multiplied together equals 0. One of them's got to be 0. Anything from 0 to 0. So we have two vertical asymptotes, and if you're taking notes, I'd probably write off to the side that's wherever you're dividing by 0. All right, and Mr. Creswell says 1 and negative 1 make the bottom 0. So and it should be an x equals when it's a vertical asymptote. So I have several rules for horizontal asymptotes. So horizontal asymptotes, we look at the biggest power of x on the top and the bottom. So in our case, we have x squared plus 2 over x squared minus 1. The biggest power of x on the top, whoa, that's not going to work, is a 2. And the biggest power of x on the bottom is also a 2. If they are the same, then the answer is, how do we say that? The coefficients?
Coefficients, yeah.
Uh-oh. That's a T. Coefficients. So what coefficient is in front of this x squared? Well, it's a 1. What coefficient is in front of this x squared? Well, it's a 1. Then we must have a horizontal asymptote at y equals 1 over 1. All right? And there are, what if they aren't the same, though? So you should probably, in your notes, say, hey, look for a biggest power of x. If they're the same, use that rule with the coefficients. Okay? So it's whatever the coefficients are. And if they're different, if the bottom is bigger, then the answer is always going to be y equals 0. It's always going to have a horizontal asymptote at y equals 0. And we can look at that in terms of limits as well. If we take, here, let's nuke this. Yeah. If we take the limit as x gets huge, limit as x goes out to infinity, what happens to this function? So what happens to it? So let's look at it graphically and see exactly what happens as x gets huge. So here is the function, and whoa, mommy dearest. Let's bring it in there so you can see it. Now, what happens as x gets huge? So x, see the x-axis down here is getting bigger.
Oh.
Whoa, mama, you're fighting me. Bigger and bigger and bigger and bigger and bigger. What's happening to x? It's getting closer to what?
1.
Yeah, it's in fact a nice crummy graphics. You can't tell that it's not 1.
Yeah.
So you can look at horizontal asymptotes in terms of limit as x approaches infinity, or how about on the other end? What happens as x goes toward negative infinity? See, here's our 1 still. If we go in the other direction, what's happening to x?
I think we're also getting really close to 1.
Yeah, it's still staying really close to 1. So we would say there's a horizontal asymptote at x equals 1. Cool, Mr. Creswell?
I'm cool.
I know you're cool. All right, attack that one while I get myself.
Okay, let's look at the domain, right? That's wherever the x values exist on the graph. So if I start from the left, it looks like if I come in from the left, it looks like all the negative x's are okay until I get to, ooh, what is that? It's like 2, I think.
Yeah.
Okay, until I get to 2. So the domain is going to be, we're all good from negative infinity until we get to 2, not including 2, okay? And then I'm going to look at this graph, and I think, remember we said we've got a vertical asymptote here?
Yeah,
Right?
at 2.
Okay. So that means that never going to be able to touch 2, but from 2, oh goodness, -2, right?
Oh goodness.
Thank you. -2. So from -2, I'm going to follow my graph around, and I think I've also got an asymptote here at +2. So from -2 to +2 without crossing it, and then I'm going to pick up here, once again at +2, not including 2 though, all the way to +infinity, all
Yeah.
the way out.
In other words, if you copied your graph, what part of the graph do you actually get to put your pencil on? You know? Well, you can put your pencil on anywhere but those 2 asymptotes. So that's another way to say it right there. And I think we should erase in between each of these here. It's going to get really bad. All right, the range of the y values. So it looks to me like here's the y-axis. Down here, it has values that are correspond to the y-axis till I get to right there. But up here it has y values. So it looks like there's a number that we jump over. I think that number is 2 again in this case, because if I look at the biggest power of x's, they're the same. The coefficients would be 2 over 1, so we'd have a horizontal asymptote at 2. So we're going to say the range is everything but 2. So -infinity till we get to 2. Whoa! Jump over 2 and then go forever. Cool?
Yep. And continuity is wherever I've got if I kind of trace along the graph, wherever I have to pick up my pencil, which is going to happen at 2, where we said those asymptotes were at -2 and at +2, right? So I think that continuity is going to be the same as our domain.
Yeah, is it always that? I'd say yes.
Okay.
I'd say yes, for the most part. So it's the exact same answer as domain. You can write that down. Oh, mommy, we're not done yet, are we? I got excited. Sorry. So where is this graph increasing and where is it decreasing? Well, if I take my pen and I follow the graph right here, is the graph going up or down?
Up.
Up. So it's increasing from -infinity till we get to, what did we decide that was, -2?
-2.
Okay, so -infinity till we get to -2. And now I'm following my graph again. What's it doing?
It's going up.
It's going up until there, then it starts to go down. So I jump over -2, and I still go until I get to 0, because this is 0 right here. Then what happens? Then, oh no! It starts to go down, starts to fall. So from 0, I'm decreasing. From 0 until we get to, what was that, 2? 2. And then it jumps over 2, and now what's the graph doing if I follow from left to right?
Still decreasing.
Still going down. So from 2 forever, it goes down just a little bit. All right, so symmetry. Holy cow, this is huge.
Okay, symmetry. The easiest way is just to look at this thing and check for symmetry. And I'm going to notice real quick that if I had a piece of graph paper with this graph on it, and I folded on the y-axis, I'd have symmetry, right? The graph would fold onto itself.
So you're saying y-axis
So I
symmetry?
think we've got y-axis symmetry.
All right. And I'm going to old school it and say, remember, to have y-axis symmetry, f of x had to equal f of -x. So if f of x was 2x squared minus 2 over x squared minus 4, what happens when we put a negative x in? So f of -x, we have a 2, and then instead of x squared, we put negative x squared. Well, what's negative x squared?
That's just x squared.
That's x squared, because negative x times negative x is a positive x. And this minus 2 is still hanging out right there. And then x squared here we replace with a negative x. So that's also x squared minus 4. Are these two identical?
Absolutely.
Yes, so it's y-axis symmetry. So not a bad little review there either. All right, and boundedness. I would say this graph is unbounded because it keeps on going this direction, it keeps on going this way, there's nothing bounding it. It keeps going up forever and it keeps going down forever. So I'm going to say it's unbounded. Does that make sense to you?
Check your affinities, yeah.
Right, so I mean, if a graph went like this, like let's say the sine curve, I would say that's bounded between -1 and 1.
Yeah.
All right, or on the y-axis. So,
Yeah.
but our graph isn't bounded because it keeps going forever. I'll let you do maxes and mins.
Oh, maxes. Okay. Well, we just said it was unbounded, so I don't think we have any absolute maximum, but I think we have a relative maximum or local maximum right there at x equals 0, right?
I like how you said local. I like that. Yep.
X
So
equals 0.
x equals 0 is a maximum. And there aren't any minimums.
No
'cause
mins, yeah.
There's nothing where it becomes a dip like
Right.
that or anything. All right. Asymptotes. Let's just look at it. Didn't we decide we had one at 2 and negative 2?
Yep.
So it's at x equals 2, x equals negative 2. Those are the vertical asymptotes. And then the horizontal asymptote, what did we decide this was at?
That's at 2, I think, the
Right.
coefficient rule.
Right there, the coefficient rule 2 over 1 because they were the same. So that's at y equals 2. Y equals 2. And my graph is really bad. I'm sorry. Okay? And end behavior. You want that or you want me to do that?
Go for it.
All right, well, end behavior, let's say what happens as x gets huge. All right, as x gets huge, we decided that this graph was getting really close to 2. As x gets huge, y approaches 2. So that's the end behavior for x going to infinity. What if it gets huge in the other direction? As x goes toward negative infinity, what's y getting close to?
2.
Y approaches 2 as well. All right, so this is true for end behavior, and so is that. So just look to see on the ends, what does it look like? All right, shall we delve a little deeper into this limit idea there?
Oh, limits are fun. All right. So the limit as x approaches 2, what's that negative?
No, isn't the negative right here on the wrong side, Mr. Criswell?
Yeah, because that can't be negative 2 then.
No, it must mean something else. In other words, it means what's happening to the graph as x gets close to 2 on the left-hand side. So if there's a negative there, that must mean what's happening on the left. What do you think this one means?
Probably on the right.
Yeah, what's happening to the graph on the right-hand side of 2? Really close to x equals 2. So what's happening to the graph there? So what's happening as x gets close to 2? Well, there's 2 right there. What's happening on the left-hand side? Well, let's take our marker and follow, the left-hand side. I'm at 1, I'm getting closer to 2, I'm getting closer to 2, I'm getting closer to 2, I'm still getting closer to 2. What's my graph getting closer to?
2.
On the y-axis.
Oh, infinity.
Okay.
Sorry.
Mr. Creswell took my class years ago, and I'm going to go back and change his grade. I'm going to say the graph's approaching negative infinity. Okay? Because it keeps going down, 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 down. All right? On the left-hand side.
Okay.
So let's look on the right-hand side. We'll give him another chance.
Can I do the right-hand side?
No! As x gets close to 2 on the right-hand side. So here's 2, and this is the right-hand side of 2. Okay, I'm getting closer to 2. Mr. Creswell, what is the graph getting closer to?
Infinity.
Positive infinity, because it goes up, 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 up. Thank you. Sorry about that. I'll let you take the next 2. All right, we got to get you a pen and some color. Go for it.
All right, so we want to know what happens to x, or what is the limit as x approaches positive infinity. So as x gets really, really big, what happens to the graph? Well, if I follow the graph as x gets bigger, 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 it's going to get really, really close to something.
I think it's getting close to 0 here. It doesn't, see how it's still
Yeah.
missing, it's going down a little
Right.
bit? It's getting really close to 0.
Okay, so our limit here is going to be 0.
All right, and then, sorry
Oh,
about
that's okay. Okay, and then as we approach negative infinity, I'm going to guess that we're going the same. We're going to get to the same value of y. It's getting really, really close to 0 also.
There we go. There we go. So in other words, it's got a horizontal asymptote
At 0.
At 0. That's
Yep.
another way to look at that too. So last shot at it again. So I'll let you do these 2 because that really threw you for a loop last time.
I think I learned it though. So
All right.
what happens as x gets really, really close to 3 from the left? All right, well here's 3.
No, it's not. That's negative 3.
Here's 3. So as the graph gets really, really close to 3 from the left, what happens?
I'd say negative
Y.
infinity. It keeps going down, down,
negative
down.
infinity.
Yeah, now be careful. This one's got a negative 3 on it.
Okay, so the next one is negative 3, which is right here. And we're going from the right. So I'm going to come at the graph from the right. Okay, excellent. From the right, what happens?
It goes up, 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 up forever, and I would say positive infinity.
Positive.
Wouldn't you?
Yeah.
All right, and then we'll change the color again. We'll go down here. What happens to x as it gets close to positive infinity? I'm going way out here. It's getting really close to 0, I think, because this is 1, so I'm assuming
Yeah.
it gets really close. And as we go to negative infinity, it's also going to get close to 0. All right.